Hello, everyone, and welcome to the Open Systems Media Webcast. Leverage the power of the Windows, IoT, and Linux operating systems for your solution. This webcast is sponsored by Arrow. My name is Rich Nass, and I will be your moderator for today. I am also the Executive Vice President of Open Systems Media, and I lead the embedded and IoT teams for embedded computing design. If you're not familiar with embedded computing design, I suggest you check it out. It has everything you could ever want if you are an engineer / developer of embedded systems, hardware, software, firmware, and everything in between. It's at www.embeddedcomputing.com. So on this webcast, you will learn that you do not have to choose between Windows or Linux, which is actually very cool. You are able to have the best of both worlds all running on the same hardware. I find that pretty exciting. On this webinar, you will be hearing from Scott Shamil, a business manager for OTSI and cloud at Arrow Intelligent Solutions. You may not know what OTSI is because I didn't, so I had to ask Scott, and it stands for Operational Technology and System Integrators. Then you'll hear from Roy Karukaran, the Director of Software Product Management at Intel IoT. And finally, Steen Graham, the CEO and co-founder of Scalers AI. Before I bring out our expert speakers, let me go through some of the housekeeping items. These guys will be speaking for roughly 45-ish, 50 minutes, and that'll leave us some time at the end to ask your questions. We will answer as many as we have time for. On the right-hand side of the console window, there's an area where you can enter those questions in real time. We tend to answer them in chronological order, so ask them as soon as you think of them. Don't wait until the presentations are over. If we do not have a chance to answer your question as part of the presentation, someone will get back to you after the webcast is over. So we answer everything, just maybe not as part of the webcast. If you have an issue with the operation of the webcast, if the audio doesn't sound right, if the video isn't going right, put that into the question box and one of our tech folks will get back to you with a fix. Also on the right-hand side, there's a handouts tab. If you click on that, you'll be able to download a copy of the slides that are being presented today. This webcast will be available in archive version shortly after we're done. So if you want to go back and review, if you want to hand it off to a friend or a colleague, it'll be there for you. We also have a couple of poll questions in here, and we would love to get your feedback as we do them. It helps us guide a little bit as part of the presentation. So it'll pop up on your window, answer it, and you hit submit, and that will be good. Okay, that is enough from me. I'd like to bring Scott Shamil out. All yours, Scott, take it away.
Thank you, Rich. Quick view of what topics we're covering. It will be introduction, going through a little bit of the challenges of AI, leveraging the possibility and what Microsoft's introduced for Windows. Talk about the Arrow AI Accelerator kit we've created and how it can be deployed. And once again, getting started and resources. Next slide. So vision is one of the types of data we use to interact with the world, at home, at work, and how we go about our daily lives. We're immersed in and responding to the information we see. The world also interacts with us through vision. Are we in a place we're allowed? Is there something we can be shown that might be useful to us? Is there something we can capture? Does that help us make better decisions? We've created and surrounded ourselves with these devices to collect, process, and present information at the edge. It can be overwhelming with the amounts of data we collect. The value lost if we cannot timely analyze and gather insight. By adding artificial intelligence to these edge devices, we are better able to process the data and collect and improve decision making. Bringing AI capabilities to the edge devices has helped us improve performance, precision, and effectiveness of human effort. It has allowed us to analyze the data faster, get more information from it and to make better decisions. AI-based computing vision can improve our capabilities in transforming every part of our life. With AI, we can perform complex functions such as object recognition, enhance safety, automation, and eliminate the necessity for people to perform dangerous tasks. Deploying AI vision solutions present an amazing opportunity to transform industries. However, many challenges remain, like how to deploy new applications along with existing applications, how to leverage existing infrastructure and avoid an expensive upgrade cycle, how to bridge modern cloud native developers applications you have running today, how to manage cost and development, deploying, and maintenance. Here are some of the challenges. Now let me hand it over to Roy so we can look at how Microsoft is addressing these with the latest release of Windows 10 IoT Enterprise.
Thanks, Scott. I'd like to start off by touching on some of the key advantages of Windows and of Linux. Windows has a large install base in Windows IoT, to be specific, has a large install base in various segments like retail and healthcare and banking. And there's a reason it's so widely used. The long-term support with LTSC, the familiarity with the programming model, Win32, legacy app support, and also the UI. It's one of the most commonly used UIs out there. Add to it the security and the manageability capabilities of Windows. It makes it an ideal solution for a lot of the deployments. If you look at Linux has a lot of developers using it for AI workloads, using a lot of the pre-validated modules, and it also offers a lot of the cloud-native programming models. Now, a developer or a SI ideally should not have to choose between the two. Ideally, we'd like to see all of these advantages being available to a developer or an SI on the same platform. And that's what you get with EFLOW. And that's what Microsoft has delivered with EFLOW. And if you can switch to the next slide. EFLOW stands for Edge for Linux on Windows. It gives us the capability of running containerized Linux workloads side by side with Windows applications. Now, this slide gives you a pictorial view of what EFLOW is. As I said earlier, it allows you to run Windows apps. For example, you can run a new WP app, you can run a Win32 app, you can continue to run those Windows apps as usual. In addition, you can run containerized Linux modules on the alongside with the Windows app or in a virtual machine running on top of Hyper-V hypervisor. This allows you to run multiple heterogeneous workloads. It doesn't have to be just Windows workloads, right? You can have Windows, you can have Linux. I'm going to touch on a few things that I've called out on the slides 1, 2, 3, and 4. The first thing is the version of Linux. The version of Linux that's used on the VM here is CBL Mariner Linux. It's Microsoft's own version of Linux. Number 2 and number 3 are most valued by an IT department, for example. You're talking about Microsoft Update. You're talking about Windows Admin Center. With Microsoft Update, you can get all of the updates for both the Windows and the Linux modules and the Azure IoT Edge modules through Windows Update. With Windows Admin Center, you have access to both the Windows side and the Linux side, so you can go ahead and do your control and maintenance from Windows Admin Center. And the fourth thing that I'm calling out there is the interop. There is a mechanism to communicate back and forth between these two VMs. For example, if you're running an AI workload on the Linux side and you want to communicate the results and display it on the Windows side, you can use this mechanism to transfer data back and forth. Now, this is very exciting for us because it allows us to easily consolidate multiple workloads, multiple heterogeneous workloads on the same platform. We call it workload consolidation. And we feel that this gives an opportunity to add a lot of innovation on Windows platforms. I'm going to talk about an example of workload consolidation on the next slide. I'm going to use an example in the retail segment of a convenience store. If you look at a convenience store, you would have a point of sale system typically running on a Windows platform, on Intel hardware. You would also have a surveillance system, a DVR and an NVR, that's been set up to monitor different parts of the store. And those things are typically running on Linux. These are independent systems, not quite talking to each other. With EFLOW, you have the capability of continuing to run the point of sale system on the Windows platform. In addition, with EFLOW, you can run the Linux platform, the Linux workload, the surveillance app side by side on the exact same platform. If you have enough headroom on the platform, you can also add some additional AI workloads. You can do some camera tampering or a theft detection kind of workloads to help monitor the store better. This is not just a hypothetical scenario. This is a scenario that's actually deployed in a few convenience stores already. So we feel that this is a very interesting workload consolidation story. Workload consolidation is one area that you can use to deploy solutions using EFLOW. There's another set of applications where you can extend what you already have. The example that I'm showing here is the industrial defect detection. In the industrial space, you would have an industrial PC running Windows IoT Enterprise. Now, what we've done here is used a OpenVINO pre-trained model that allows you to do defect detection on the same platform running on Linux. So it's a Linux-based pre-trained model. And as you can see, it has three classes. There's a no weld option, or a normal weld, or a one that has a defect. If it's green, it's normal weld. If it has a defect, it shows up in red. So this is a quick example of how you can easily extend an existing Windows-based industrial PC with a Linux-based pre-trained model. Another example would be in the retail store. If you have digital signage in several retail stores, the content and the video is being served up from a Windows machine typically. If you as a retail store owner want to get better audience analytics, you want to have a better idea as to who's coming into your store, you can go ahead and again run a few pre-trained models on Linux using EFLOW, where you can get much better audience analytics, and you can serve up your content better depending on who is in front of the screen at that time. The last example that I want to show here is a surveillance system, a VMS system that could be running on Windows. Depending on the headroom that you have on a VMS system, you can run some additional workloads. For example, you can do object detection. That would help you with identifying unattended baggage or other hazards in an airport setting like we're showing here. I quickly walked through 4 different scenarios on those 4 slides. My intent was to show that EFLOW is a horizontal technology or a horizontal capability that can be applied to multiple segments. It could be retail, it could be industrial, it could be surveillance, it could be healthcare. But the idea is EFLOW is applicable to several segments out there. Let's talk about why EFLOW. I'm going to talk a little bit about why it's important for developers, and then I'll talk about why it's important for system integrators and end customers. For developers, like I touched on earlier, it gives you the best of both worlds. You have the familiar programming model with Windows. You have the capability to use cloud-native technologies with Linux. You can go ahead and use both. You don't have to go ahead and choose one or the other. The other big advantage for developers is the reuse of existing code. There are trillions of lines of code and pre-validated libraries available for both Windows and Linux today. If you have a Windows application and you're trying to get some AI models going, you don't have to figure out a way to port all your Windows applications to the Linux side and then implement everything on Linux, or vice versa. You can go ahead and just continue to use your existing apps, reuse your existing code that's already been developed for Windows, and then include a lot of the new AI models, if you will, on the Linux side. From a system integrator perspective, you can just focus on delivering or developing your solution for that's most relevant for your end customer. You don't have to figure out how to set up the platform, create the VM, set up the hypervisor, address all the licensing issues, because all of that is already pre-packaged for you with EFLOW, and the whole thing is set up. So you can focus on delivering your solution itself. The other thing is protecting and extending the investments that you already have. How do you maximize the use of your hardware? If you have additional headroom on the deployments that you already have, you can go ahead and maximize it. You don't have to sit there and say, you know what, I need to add more capability, but for that I have to buy new hardware. You don't have to go with that. You can maximize what you already have. Now, quicker time to market and ease of deployment, especially if you are a Windows shop. If you're a Windows shop and you have a need to deploy Linux, you don't have to go through the effort of setting up the Linux infrastructure and getting this whole thing up and running. It's much easier because these EFLOW based solutions do show up on a Windows box, so you can continue to use all of your Windows maintenance and support tools and infrastructure that you already have. I'd like to talk a little bit about some of the work that Intel has done and what we are delivering for EFLOW. As you can see on the chart here, EFLOW runs on pretty much all of the Intel processors, whether it's an Atom processor or a Core processor or a Xeon, it runs on all of them. What we have done at Intel is we've worked with Microsoft to make the integrated GPU compute available on the Linux side as well. So for example, if you are trying to run a AI workload on the Linux side and you want to better accelerate that workload, you have access to the integrated GPU compute through OpenVINO running on LTSC 2021. And that is important because you can accelerate your workload using both the CPU and the GPU, taking full advantage of all the hardware that you have on the platform already. The other thing that we deliver is the EFLOW BKC. BKC stands for Best Known Configuration, where we deliver a fully validated software stack. The BKC lists all the components of the software stack, so that if you as a developer want to get started, you can just take that BKC and start off from that fully validated baseline, and you can just focus on delivering your solution, knowing that this configuration is fully validated. With that, let me hand it off to Steen to talk about the solution accelerator.
Thank you, Roy. Roy and Scott did an incredible job of highlighting this really foundational technology from Microsoft and Intel to enable these no compromise workloads between Linux, between Windows, with hardware acceleration on Intel's integrated graphics. Incredible capabilities, I think, that have an incredible value to transform industries and enrich lives. And one of the things, though, that Scott mentioned is that the complexity of deploying this type of technology in the physical world is so great and substantial. And what we wanted to do is dramatically simplify that complexity. And so what we're launching today is the Aero AI EFLOW Solution Accelerator. And this Solution Accelerator is a full stack edge to cloud reference solution that comes with solution code available through GitHub, step-by-step developer training on how to provision all of these incredible services like EFLOW, like getting that iGPU-based acceleration up and running, optimized on Intel hardware platforms, both from the Intel NUC community and from Lenovo on their SE30 platform. And it also comes with a sample application that we've deployed today, or showcased today, in smart port applications. And that extensible platform can apply to any of those vision use cases that Roy and Scott alluded to earlier on the call today. So I'm going to take you guys through this implementation that we used for smart ports And then we can talk a little bit about the extensibility to other AI vision applications as well. And so one of the things you guys have probably noticed in the world today is there's a huge challenge with the supply chain. The time it takes to get a container out of China, out of the port of Shanghai, into the port of Long Beach or Los Angeles is huge. It's grown from on average basically 70 days over 110 days. The cost of that, normally it'd be about $1,500 per container, has grown to over $15,000 per container. So how can deploying modern AI infrastructure, in parallel with Windows help out? Let's talk a little bit about how we can optimize the turn times and the crane operations in this smart port application to help this challenge. So one of the things that you'll find if you look at the California Maritime Association, they say it can take up to 8,000 trucks to unload a ship at a port. And one of the things that we're seeing challenges with is the truck drivers and the truck drivers' ability to get to the right place at the right time. Some information says there's about a 50% no-show of truck drivers. And one of the areas that we've got to be able to unload and load up those containers on those trucks is through the RTG crane operations, the rubber-tired gantry crane. That's the critical facility in doing that. And so what we're doing in this application is we're actually going to monitor the turn time or the operational technology metric of how fast those trucks can be loaded and unloaded. And one of the most important things, though, at ports is safety. The safety of the employees at the ports is job one. And given these cranes are big physical machines, we need to make sure those workers are safe. So in this implementation, we're actually using AI for enhanced worker safety insights. And you'll see that's where we bring the magic of Windows and Linux together, because in that worker safety application, we have an existing Windows-based notification manager for the crane operator to notify them when it's safe to proceed. So let's take a look at this edge architecture, and you'll see this is very similar to a lot of the architectures Roy alluded to today. This one we implemented. And so in this particular architecture, what we're doing is we're showcasing that Windows-based environment. And one of the values of Windows that we're showcasing here is what I alluded to, is that alarm notification manager. That's a Windows-based application that notifies the crane operator when it's safe to proceed. As you can see from the video that's playing here, there's a number of workers at the port, and we need to notify the crane operator because they have obstructed views when the workers are out of the way and it's safe to proceed. And so we're using the Linux-based environment to ingest that video feed from the camera and notify the operator when the workers are out of the way. And we're notifying them versus using a machine-to-machine protocol, OPCUA server. So the Linux-based AI environment actually detects when it's safe to proceed for the workers or not safe and notifies that existing Windows application using the OPCUA client application. So that's how we're communicating between Linux and Windows in this particular example. We're also running multiple models because remember, we want to look at that OT metric, that turn time metric of how fast the truck can be loaded and unloaded. So in this implementation, we're using OpenVINO's license plate detection, and then we customized the reading capability using an open source project called Tesseract, so we could both do license plate detection, vehicle detection, and then read that particular license plate as well. And this architecture, as I noted earlier, is not just an edge-only architecture. We've used for development the Azure Container Registry. We also use the EFLOW edge deployment and manifest tools through EFLOW. And then we built 2 dashboards because, as you probably realized, the batch analytics are very interesting. How fast the truck loaded, unloaded, are there any safety incidents? But as a site manager or a port manager looking across terminals, you're going to want those batch analytics to pair with those edge analytics as well to understand where your bottlenecks are, where you have opportunities to improve throughput as well. And we created 2 dashboards, one in IoT Central and one in Splunk, just for that as well. So I'm going to show you that. So this is the implementation from an operator view. So we're showcasing here what is a really common operator interface for an RTG crane operator. And you can see right here, the license plate is detected. It's pulling up the entry time, the work order ID, the container ID. And so all that information is going from the operational technology environment to the IT environment. So we can start analyzing turn times and performance. And then in the other camera feed, we're showcasing that AI-based tripwire detection zone and people detection zone and notifying the operator if they have any safety alerts to tell them if it's safe to proceed as well. And in this environment, this is actually the environment we've created that's running on top of Windows. So you can say in the last slide, we're running on top of Linux. This is running on top of Windows. And a couple of notable elements here is we're showing that we're simulating that machine-to-machine protocol communication between OPC-UA. So now we're notifying if there's an employee that's entering that tripwire detection zone, and then notifying that Windows-based app, that alarm manager app, that it's safe to proceed for the operator. One thing I should note is a lot of these RTG cranes have Windows-based operating systems within them, like Siemens Simo Crane, for example. It's a very prevalent OS in those facilities. And perhaps, really importantly, if you see down here, we're running the AI in Intel's integrated graphics. And this is something that Roy touched on. This is something that was just launched within the last few months, where you can get that AI performance through Windows in your Linux-based environment and get that hardware acceleration. It's very important, especially if you want to run your existing Windows and Linux apps and then run multiple AI models, multiple camera feeds. And you can do that without buying an expensive GPU or upgrading your infrastructure now, given that great technology from Intel and Microsoft that they partnered on as well. All right, so let's take a look at the batch-based analytics as well. So, on the IoT Central view, we're just looking at that OT metric, that turn time. We're also looking at people on site, so we can analyze any particular safety violations. We've got that all up and running in our batch-based analytics here. Now let's transition to the Splunk analytics platform. One of the biggest goals that ports have right now is to reduce fossil fuel emissions. And one of the things I didn't mention earlier is these RTG cranes are fossil fuel burning machines. It's about 10 gallons an hour. Now, some ports have hybrid cranes and they mix it out. And so with the Splunk analytics, what we're doing is we're looking at fossil fuel emissions as well as overall fuel costs, and then also that turn time safety violation insights up and running as well. So we've got all of that integrated from that edge instance we're running, or multiple edge instances we're running, all the way to the Splunk dashboard as well. And of course, what I alluded to earlier is this technology, the Arrow AI Solution Accelerator that we built for this, is extensible to other use cases. For example, here we're just using that same tripwire detection capability that we're using for worker safety to analyze customer insights. Are they looking at high value assets? What are the zones in the store that they're particularly interested in as well? So, in summary, we've created this solution accelerator that's going to dramatically simplify provisioning all these fantastic services from Intel and Microsoft to enable these technologies. Gives you multiple AI models that we built as well, complements the Intel and Microsoft technologies with other capabilities like the machine-to-machine protocol OPC-UA, so you can communicate between Windows and Linux. We have a developer training series that's 17 steps that will take you step by step through this progression. You can get the solution code available. We've also got more sales and marketing training and additional training materials, and we validate it across multiple platforms. And you can get access to all this, save yourself hundreds of hours of development time and work by reaching out to Arrow through this webinar. So great opportunity to contact with the team at Arrow and get access to these fantastic technologies and apply them to solve some of those industry problems you saw from Scott and Roy earlier today. Now I'm going to transition back to Scott for a summary.
Thank you, Steen and Roy, for all that information. I'm really excited about the Edge AI Solution Accelerator and how it can help our partners get quickly start with innovation on their own solutions using EFLOW. I'd like to take a few moments to summarize, and then we can move to Q&A. We covered EFLOW and how it can fast track innovation and provides the flexibility to consolidate hardware offerings with the best of Windows IoT and Linux on a single platform. We talked about how to accelerate your vision applications by leveraging Microsoft EFLOW and Intel's OpenVINO. We introduced the Arrow Edge AI Accelerator that was created to save hundreds of hours of development time for your projects. And finally, we'd like to make sure you have our contact information in order to get access to the Arrow Edge AI Accelerator GitHub resources. My contact information is on the slide. You can reach out at our generic email, msembedded@arrow.com, or my personal email at sschmill@arrow.com. Thank you once again for that and your time. Let me hand it back to Rich for Q&A and reviewing the poll results.
Thank you very much. Okay, so let's read these polls before we get into the Q&A. First question, in your current environment, are you currently using Linux but would prefer Windows to perform the same function? Are you using Windows today but have had needs to run a Linux application? You have both Windows and Linux devices, and there would be a benefit to combine them on a single device, or none of the above. What do you think, Scott?
I'm thinking, B and C looking pretty interesting, that people are both interested in using Linux applications and in some cases already using both Windows and Linux. So EFLOW aligns with those goals and should provide new tools to develop solutions.
Okay, I don't know if you were reading the results or you have some really good intuition, but that is what was the two most popular responses. Using Windows today, but have needs to run Linux applications, was second to having both Windows and Linux devices, have both devices and a benefit to combine on a single device. That's what I would have expected. And that's actually the purpose of this webinar, because we've helped people to do that. Okay, and then the second poll question is, would you like to have consultation with one of our experts? Of course you would, right, Scott? Why wouldn't you?
Well, I hope we have a lot of yeses here. Once again, EFLOW really brings some new value and some new capabilities for you to deploy and start investigating. We know it takes design cycles, and the exciting thing is this opens up to solutions that maybe weren't possible before. You had isolated Linux workloads and Windows workloads doing two different things, two sets of hardware. Now you have some really interesting opportunities for your marketing and your dev teams to come up with things that you never thought of before, or couldn't be done before, or were cost prohibitive.
Yep. And the survey said, yeah, about 2/3 of the people said, yeah, definitely reach out to me. And 1/3 of the people said, nah, I'm good. So that's where we are. Okay. So now we are going to get into the Q&A portion of our webinar. So as I said, ask now, and hopefully we can get you some answers. If we do run out of time, one of these guys will be responding to you directly, probably via email. So let's see. Okay. I like this question. I would like to know how the app on Windows and Linux can talk to each other. Is there some kind of internal process communication or IPC that we can use, or do we just find a way via the database?
Well, the last example, we use the machine-to-machine protocol, OPCOA server and client for the communications. You can also just take, standard communications protocols like, the camera RTSP feed as well to communicate as well. So it just depends on the business application and the APIs associated with the application between both of those environments.
Okay. Anybody else want to chime in there? Are we good? Okay. So next question. Hopefully you'll answer this. What exactly do we get with the Arrow Edge AI Accelerator?
So first of all, we're not charging anything. It's a repository of information and some pre-validated hardware we have identified. opportunity to buy the hardware on your own or look at Arrow, depending on your end use application. The repository, what we're providing is all the code. We're providing the instructions. So step-by-step instructions with videos. And I know Steen's going to dive on this a little bit more. We're also providing, the model we're doing is obviously for the smart port and how we implemented it, but there's some documentation on how to change the models out, because what you're going to do and what smart port is are probably two different things. We want you to have it up and running is the objective here, to get that learning curve behind you, be able to deploy a known good model. You can reach out to Arrow to provide support for that, work you through, and if you have roadblocks, talk about them and how we can help you do that, and even leverage professional services that if that's what you need. The key thing is we want you to, once again, to have something up and running before you start off with your own solution, your own implementation, your own models, where if you run into an issue, you haven't actually proved that you can deploy the process. Steen, would you like to add to that?
Well, I just think, ultimately, I think the most expensive costs we have, in the world today, and when we all make investments is in, humans, and, developers are extremely expensive, and the time of developers is so valuable. And, the thing about this solution Accelerator is it's going to save you hundreds of hours of developer time and enablement. The things that I would allude to as well is some things like setting up that iGPU para-virtualization driver, such an incredible technology from Intel and Microsoft, but not easy to provision and set up. So the tutorial will dramatically reduce that learning curve and enable you to access that technology. So you don't have to buy expensive GPUs. You can just use off-the-shelf hardware from Intel. So that's a great capability as well. And then, just want to allude to like some of the things that we're offering in the solution code, like the OCR based license plate reading, using OpenVINO for detection, but using OCR for based reading. In many companies, that's a paid model as well. So that's paid AI models as well. And so there's a huge value in saving hundreds, if not thousands, of hours in development, and actually being able to deploy some of this cutting edge technology from Intel and Microsoft that you may not easily be able to deploy as well. So I would be thrilled to get jump started on this. Having actually went through the process of building the technology, it would have been nice to have this Arrow Solutions AI Accelerator a few months ago after thousands of hours of engineering work. So you guys don't have to go through all that pain and suffering that we did.
Yeah, and I think that's a good way to point it. The intent here is to get you up on the learning curve quickly. It demonstrates some success so that as you work on your solution, you have a reference of success and how to continue and evolve with your development. And I'll add that, besides the models we have, OpenVINO from Intel, they have all kinds of existing libraries for other types of vision AI out there. So there's a lot of things you can remove and plug in where the code exists as a starting point for you already.
Okay. Is there any qualified hardware beside the Lenovo SE30 and Intel's NUC XX?
So we can talk. We focused on a Gen 11 Intel processor, i5, i7, just for the purpose. The main intent we focused on those two platforms was we wanted to have a known good to be able to support you with. We understand you might have unique I/O hardware requirements, feature sets that hardware doesn't fulfill. Through Intel, we do have a list of pre-validated hardware from some of our other ODMs that we can share with you. And we can talk about if it's not on that list, what other kind of hardware would meet and what the criteria for that is. So the intent with having two platforms pre-approved was to make sure we had a known good to start with. Once again, we don't want you to be deploying on a hardware that we haven't had a chance to look with and get distracted with troubleshooting hardware issues out of the gate. We wanted to demonstrate that quick success for you deploying a model, reproducing the accelerator. Yes, you can use other platforms, and we can help you identify what other platforms are a good fit. As Roy pointed out, the whole Intel ecosystem, or a majority of the Intel ecosystem, is going to support this feature. There are certain things what we can say are help or improve, whether it's the BIOS, how the BIOS is set up by the ODM, the IO you might need. Roy, was there anything you would add to that?
No, I think you captured it right, Scott.
Great. Like I said, we'll work with you to get that hardware. Hardware is hard to get, and there's our lead times out there. Once again, we wanted to give you a starting point, a known good starting point to start your development on.
Yeah, I would just add that 11th gen core, processors from Intel, showcase fantastic performance. And if you're going to run multiple camera feeds, multiple AI models, you probably want a system with a fan. And but there's a ton of validated models from different Intel partners that Arrow carries on their line card as well. So, there's a ton of great 11th gen core products from across the ecosystem that you could leverage for this solution.
Yeah, and I think we even have the Gen 12 coming out soon. But we did test on multiple platforms, prior versions of the Intel NUC, and saw how tremendously good performance the Gen 11 processor did.
Excellent. Okay, so next question is, what are the prerequisites for EFLOW?
Steen, do you want to take a stab at that?
Well, I think Roy touched on it really well in his presentation. I mean, you got to, you want to start with, the Windows, IoT LTSC version. I mean, that's so important and so foundational. I think a lot of people that miss that, have to come back and do a lot of rework. So that's something, that's foundational at the onset. And then we've got, Intel has a number of, platforms that are fully supported for EFLOW. I mean, we just talked about 11th gen core. You can go back a couple of generations as well and get supported platforms from Intel as well that Roy can highlight as well. But there's a couple of legacy generations of platform support as well that I think is great. From Intel went above and beyond to support legacy apps, which is super cool because in that scenario, you can take existing hardware you've already deployed and now with Windows and now run modern AI applications without buying an expensive discrete GPU on existing hardware. So I think that's great. And then obviously the 11th gen core is going to perform even better. Roy, anything you want to touch on for prereqs?
Yeah, the easiest way to look at it is look for platforms that Intel has validated on LTSC21. There is a link. You can search for it on the Intel website where we actually list all the processors that support LTSC21. And those processors will also support the GPU acceleration that we talked about.
Yeah, and I'll just repeat, Steen and Roy both pointed out, there's an opportunity for existing hardware you've deployed to add additional capabilities. I know we emphasized Vision AI for this particular accelerator. We felt it was a good usage model, but it's really a Linux containerized workload. It doesn't have to be Vision AI. There are lots of things, modern loads that you develop in the cloud, machine learning, besides AI, functions can be, those types of things are being developed by your teams in the cloud and can be pushed out and maintained on these devices. So there's a huge opportunity. Of course, Vision AI is a nice visual one. It's a great demonstration, but don't limit yourself. It's any Linux containerized workload.
Yeah, I would just allude to too. I mean that we get so excited about how computer vision has exceeded the capabilities of the human eye, and therefore we talk about Vision AI. But time series based data, is also a great application to run AI on as well. And then just reinforce what Scott says. You can run just common Linux applications, on top of Windows as well. It doesn't need to be that. And as far as other requirements you think about is, this is fully cloud native development by Microsoft. So you just want to, all the, if you can get a little bit of Azure account set up and all those capabilities from Microsoft, you can get a great jump start on deploying this technology as well from a prerequisite perspective. And you'll get that all in our developer training content. The README file will walk you through all the Microsoft services and prerequisites you need.
Yeah, now Steen points up a good point too. You have developing teams who are developing on Linux at your organization, and you might have developer teams who have Windows as well as legacy Windows apps. Now you have the opportunity to bring that all to one platform. talk about the power where your development teams are, you're maximizing the development and the ability what you can do on your platforms now. The best of both worlds.
Very good. To the person who asked, is eFlow limited to AI and vision? I think we answered your question without you even having to ask it. So I'll move on. And we got into a little of this next question too, but I'd like you just to follow up, just to be sure we answered it completely. What are the hardware requirements for eFlow?
Go ahead.
I can take that. I think we touched on that also. eFlow by itself runs on pretty much every platform that, if you're talking about Windows IoT, it runs on every platform that runs Windows IoT, LTSC 2019, RS5. If you're looking for the graphics acceleration, the integrated graphics acceleration that we talked about, then that's supported only on some of the, I believe, Gen 8 or Gen 9 onwards. So obviously, 10, 11, 12, and all are supported, will support the integrated graphics acceleration. So min hardware, anything that supports RS5, but CPU only. If you want the GPU acceleration, you have to have LTSC 21.
I will mention, I know we've talked about Windows 10 IoT Enterprise Long-Term Service Channel, LTSC 2021. If you're not familiar with that, it's based on the same kernel as Windows 10 Pro with additional lockdown and security capabilities, ability to lock down your product. It's available through the Microsoft IoT channel, formerly the embedded channel. Long-term service channel means that it's supported by Microsoft for 10 years. That means 10 years worth of patches and security updates. It was released in November of 2021. So it's supported until January 2032. It's a long time for an OS being supported. And that's why Microsoft makes the IoT channel available. If you need more questions, reach out to the emails I gave you, and we can definitely talk and give you more information on that. If you're not using it already, it's something you should really be considering for your Windows workloads.
Okay, let's see. What is the next question? We do have a whole bunch of questions here. So let's see what we got. Oh, before I do that, I'd like to invite Chetan Gadgil to join us, because I know he's in the background. He's chomping at the bit. He's with Scalers as well, and I know he would like to respond to some of these. Was there anything in particular, Chetan, that you wanted to respond to before I move on to the next question?
Yeah, so I think, thanks for the introduction. There were a couple of questions on WSL2. So I think one of the questions was, can we develop on WSL2 and deploy on eFlow? That's a great question. I mean, that's a great way to deploy, in fact, because the same driver that Intel and Microsoft have enabled, it also works in WSL2. So you will get the hardware acceleration in that environment as a developer. And the eFlow environment is a target deployment environment. And because of the way Azure is set up, you can actually just have a nice little VS Code on your WSL to have a virtual eFlow environment and do your development testing on the same platform, as well as use a typical, let's say, IoT class device at the edge once you're ready to deploy.
Okay, let's see. What is the framework of the pre-trained model? If as an integrator, if we would like to retrain for a custom data set, will it be possible?
Yeah. So I can take that. So in this particular example of the solution accelerator, we have deployed OpenVINO, which supports multiple frameworks, actually speaking. So meaning for different kinds or different types of tasks like object detection, image classification, and others. OpenVINO has support for YOLO V3, TensorFlow, PyTorch. The example that we have in the solution accelerator is based on TensorFlow. You can retrain those models, so it is pretty well documented in the Intel OpenVINO documentation how to do that. There is a tool, transfer learning extensions, which you can use to take your custom data set and do transfer learning or incremental learning on top of existing models. That's the typical process for OpenVINO, and it does support multiple frameworks, and it is documented on the Intel website.
Yeah, I'll add there too is keep in mind as your model evolves and you have more data sets to add to your model, you can of course via Azure deploy those or update those models out to your endpoint devices. So you have a dynamic ability to control, evolve those containers out on the edge.
Okay. Related to the required hardware, what's the baseline footprint for Windows 10 IoT and eFlow in terms of memory and storage?
Oh, I'm going to get this wrong, but I think it's there's a minimum requirement for Windows 10 IoT Enterprise. I believe it's 2 gigabytes is what's listed, and 16 gigabytes of storage. That there is some things to optimize that for the Windows 10 IoT. Microsoft provides instructions on what services can be shut down and eliminated. It is possible to get it down to 1 gigabits of memory. Keep in mind that doesn't include the workload, the AI models, and the containers. So we're just talking about Windows 10 IoT. Depending on how many your AI workload, how many cameras, for instance, for vision, how much overhead you need to operate those efficiently, you would have to add memory and obviously storage for what you deploy out to the product.
Yeah, and you can configure that. That's a great answer, Scott. And you can configure that. So in the solution accelerator documentation, we have shown how you can configure depending on your use case. For the eFlow portion, you can carve out a portion of your RAM and your space for the eFlow based workload. And let's say if you have a very large model or large amount of workloads on the Linux side, then of course you'll need more resources there. And the bigger story here is, of course, on this hardware acceleration that you get. I mean, you could have run a VM in the past too, but what this new thing's offering is the ability to get the hardware acceleration all the way from the hardware to your Linux-based Windows containers, and because of which your typical processor requirements are going to be lower than they would have been. But on the other hand, yes, memory and storage are obviously dependent on your use case.
I will add, we didn't highlight it too much, but as you start using that iGPU, what you start doing is freeing up CPU for your other workloads. So where you could have ran acceleration on the CPU itself, now you're offloading it to the GPU and therefore opening up more compute for your other applications.
Okay. One of the other challenges with Linux and Windows in the past was the networking stack. What has been done to improve the stability of networking for both the Windows and Linux systems? I like that question. That's a good one.
Yeah, so I can take a part of that. So basically, the communication between the Windows and the eFlow environment, the Linux environment, it is through standard TCP/IP mechanisms, right? So it can be UDP or any other mechanisms. So Steve gave the example of OPC UA, which we are using for this particular accelerator, as well as RTSP, which happens to be UDP. It also supports UDP. So in terms of the stability of it, because of the way, and that's the reason why the Windows LTSC, the long-term support channel, becomes so important. Because if you go to the eFlow documentation, they do support other versions of Windows too, Windows 10, Windows 11, Enterprise, Pro, all those different things. But the reason why it is important to use this kind of a long-term type of a product as a base is that the hardening that both Intel and Microsoft had done to support and validate different types of communication scenarios, that is also very important as a part of the LTSC portion of it. But of course, on paper, it supports, or at least in the documentation, it supports multiple types of other Windows platforms too.
Okay, let's see what else we got here. We had a couple people ask about the replay of the session. It will be available in archive version shortly after we're done, so you can download it. Can I run eFlow on premises fully isolated?
That's another great question. So
yeah,
but you can't run it. You can run it intermittently isolated, but not fully isolated forever, because it's cloud native in its implementation, and you don't get all the benefits from the Azure services. And as Scott alluded to as well, is you get more data, you're going to want a continuous learning loop. constantly retraining your model as well. So there's security upgrades, from, malicious issues. I mean, there's always reasons to have intermittent updates. But the great thing about EFLOW is just like you get the best of both worlds between Linux and Windows, you're also getting kind of the best of both worlds between running on-prem and cloud, because you're getting those cloud updates when you need them intermittently as well.
I will add, we live in a world where not everybody has continuous connectivity, especially in the industrial automation, some of these distant edge deployments. That is supported, that's understood. It's the ability to fully leverage some of these capabilities get lost when you don't have the ability to occasionally check in. I'm thinking from oil and gas, mining. Obviously, that when that truck goes down into the mine, it might not have a Wi-Fi, a hotspot, or a 5G connection a half a mile down in a mining pit. But when it comes back up and checks in, it gives it an opportunity to update. Same thing, oil and gas, all these different industries. I live in a place with horrible cell phone connection. It's not required to be continuously connected, though. With digital transformations, there's lots of opportunity for you to add more value, more services, and more opportunities for you to charge for those services to your customers when you connect to the cloud.
Okay, we're starting to get out of time here. Can you deploy the solution Accelerator on Intel Edge Developer Cloud?
What's great about Intel Edge Developer Cloud is you have the capability to test your AI models on Intel's vast portfolio of hardware. It's VPU technology, it's integrated graphics, all the way from Atom, Core to Xeon. And it really has strong capability in being able to test the models there. So if you wanted to take some of the models that we've built and test those for performance to make a different hardware selection, you could use the Intel Developer Cloud for that from an AI model perspective. If you get the solution code and you look at the README file and you pull those out. The full stack solution wouldn't be available through the Developer Cloud for the Edge, because it's focused on solving that problem of making sure you make the right selection for your AI models.
Okay, let's see. One more. How do I get access to the solution Accelerator?
Reach out to me via email. The intent here is not that we're not wanting to share the data, is that when we give you access to the Accelerator, the GitHub repository, our expectation is to also work with you and answer questions and help you with some support, be engaged, make sure you don't run into roadblocks. Therefore, we're just not making a public repository at this time. We're supporting it. We're reviewing your questions, and through the GitHub as well as through email, we can have those conversations.
Scott, I'm not sure if we gave your email address out. Do you want to do that? You just told people to contact you by email.
2 email addresses, msembedded@arrow.com. So MS embedded. The other one is my first initial, S, last name, CHMIEL. So shamil@arrow.com. They're in the summary slide of the presentation as well.
Okay, you can add it to every list known to man now.
Yeah, I'm waiting for your cell number, Scott.
And your bank account number too.
Yeah,
very good.
And your,
all right, guys.
Your Instagram handle.
Awesome.
But I'll add. But obviously, I'm not a software person per se. It's going to be the expertise. We will give you access to further questions, and if the right team members weren't on this call and you need help disseminating this up within your organization, your CTOs, your marketing, people who own the platforms, we want to have those conversations. We know this is a lot to take in. We covered a lot today, and we really compacted the number of slides down to give you this high-level overview. So we're really ready to dive into more specifics with you, your teams, and start talking about specific usage models around the hardware, around Intel, and around the Windows 10 IoT enterprise, as well as this particular feature. So we're really excited to go that. We know there's more conversations to go to help move it forward in your organizations.
So what are you waiting for, right? Isn't that what we say? Okay. I want to thank you guys all for your excellent presentations and for answering some questions that were more on the difficult side. I'd like to also thank Arrow for sponsoring this event. And of course, we could never do any of these things without you, the engineer. A final reminder that all Open Systems Media webcasts are copyrighted and may not be recorded without prior permission. So thank you all for attending, and I hope you have a great day.
Thank you.